On March 1, 1954, the Atomic Energy Commission of the US government detonated the first hydrogen or the thermonuclear bomb on the islands of Bikini Atoll. And the energy produced by that bomb was equivalent to roughly 6 million tons of TNT and was 1,000 times more powerful than any of those atomic bombs which were dropped on Hiroshima and Nagasaki during the World War II. After detonating the bomb, the US government collected the debris from the atmosphere which was produced from the thermonuclear explosion in order to find out some rare and radioactive isotopic elements. And it was from this nuclear waste that they discovered another element, and they named it after one of the greatest scientists of all times, Albert Einstein, and they called it Einsteinium. In this video, I'll be diving into the depth knowledge as to how a hydrogen bomb is actually made and how it was used to discover the element Einsteinium, as well as the modern research going on with reference to Einsteinium, and also a very interesting story with reference to two of my favorite nuclear chemists, Albert Gierso and Glenn Theodore Seaborg. The main difference between a hydrogen bomb and an atom bomb is the type of nuclear reaction. In an atom bomb, there is nuclear fission going on, wherein you take a very heavy atomic nuclei like uranium 235 and we bombard it with neutrons. After that, the nuclei splits to give off lighter elements as well as more neutrons. These more neutrons then trigger the nuclear fission reactor in other uranium 238 atoms to produce a chain reaction. In this chain reaction, at every single nuclear decay, there is a loss of mass. The mass of the product is actually less than the mass of the reactant. So where does all that mass go? Well, all that mass turns into energy. According to Einstein's mass energy equivalence principle, or E equals mc square, energy can be directly converted into mass and mass can also be directly converted into energy. And all that mass converts into energy, even though it's a tiny amount of mass, but it produces considerable amount of energy in this chain reaction. On the other hand, a hydrogen bomb is just the opposite of an atomic bomb. In hydrogen bomb, there is nuclear fusion going on, wherein you take two smaller atomic nuclei and bring them close enough such that their electric repulsion is actually overcome by the strong nuclear forces which are carried by the gluon force carrying particle, and such that these two small atomic nuclei actually fuse together to form a bigger nuclei producing energy from the mass itself. The only problem was that nuclear fusion required a temperature of about 100 million degrees Celsius, which was almost impossible to reach over here on Earth. Therefore, scientists came up with a solution to this problem, and that was that they used nuclear fission reaction in order to reach that temperature requirement and trigger the fusion within the hydrogen bomb. So this is a missile within which there is a hydrogen bomb in a conical cavity. Now in this conical cavity there is a fission bomb which is based on nuclear fission. There is also a chemical bomb on the outside covering the fission bomb, and a third bomb which is the fusion bomb. This entire setup is seized within a line of beryllium mirrors which reflects off neutrons and concentrates the fission reactions. In the fusion bomb, there is a uranium casing and a plutonium rod which undergoes nuclear fission reaction reaching a very high temperature. The green part represents the fusion fuel, which is a chemical known as lithium deuterite. Lithium deuterite is a white colored powder which is created by the reaction of lithium and deuterium gas. The hydrogen bomb starts with the detonating of the chemical explosives on the outside, which creates a condition for the nuclear fission reaction to occur in the fission fuel made up of uranium 235 or plutonium. This fission fuel is actually enseized within a sphere made up of these beryllium mirror castings. These beryllium mirrors reflect off neutrons, which produces more and more amounts of these nuclear fission reactions and increases the temperature. The first and the second bombs are actually separated by a styrofoam coating. After detonating the fission bomb, the styrofoam turns into a plasma because of the intense heat created due to these nuclear fission reactions. The styrofoam plasma then lets off gamma rays and X rays, which concentrate their energy into the fusion bomb after being reflected off the beryllium mirrors. These X rays and gamma rays reach the cylinder first as compared to the shock waves and trigger the nuclear fission reaction within the uranium casing and plutonium rod, which increases the temperature to about 100 million degrees Celsius for the fusion reaction to occur. At this temperature, the lithium deuteride reacts with the neutrons produced by these nuclear fission reactions to create tritium, another isotope of hydrogen. This tritium then fuses with the deuterium from the lithium deuteride to produce helium-4 and another neutron. And in each process, a large amount of energy is released. And also, since more neutrons are released, these neutrons then trigger another nuclear fission reaction within the plutonium rod and the uranium casing and produces a ton of energy, which could rip apart everything.
The distance of the camera aircraft is 50 miles. The frame size of the picture is 14 by 18 miles. The film is running at normal speed.
Now for the Einsteinium part, I will cover that in a future video in the part 2 of this series, along with the modern research with Einsteinium as well as the story of those two nuclear physicists. So stay tuned. And thanks for watching.